Hello, I'm Richard Sievers.
And I'm Walt Mayer.
Today we're going to do a walk around of the 8000 series Deere tractors. Walt, I see they've made a significant number of changes to these 8000 series tractors. Can we take a look at some of those major changes?
You bet. They've made a lot of changes, all right, Richard, but there's one change they did not make. They did not put a tilt hood on this new Deere tractor like we have on our Magnum tractor. Now, the owner's manual instructs the owner to remove the hood every 750 hours to check the connections that are underneath this hood. Now, this is quite a job because number one is you have to remove the grill, and then you have to remove 12 bolts that hold the hood and the side sheets on the tractor. Now, you want to see what's under the hood? Let's get started. If you'll grab hold of this other side here, we'll get this grill off.
These bolts out, Walt?
Yeah, take that bolt out of that side here.
Hey, Walt,
Yes.
I dropped the bolt. How do I get it out from under the radiator?
You better go try to find a magnet and pull it out.
Haven't got this one out yet. Pull the back bolts now?
Yeah, get those back bolts off there now.
Okay.
Don't drop it this time, okay? Well, they got enough bolts on this rascal.
Got yours out?
Well, it's about out. Well, I better get this electrical wire that hooks up the headlights unhooked here. Let's see, boy, that's tight up under there. Okay, Richard, let's get this hood off. Here, I'll get on back here. Hey, I think we're gonna need some help.
Wow, Walt, that was quite a job getting that hood off. How long do you think it took?
That took about 15 minutes, Richard. It really did. Boy, when you get the grill off there, you can sure see these hoses out in front of the radiator. You got to cut down the airflow through the radiator, don't you think?
I bet it does.
Yeah.
A lot of other hoses and tubes and wires and stuff over here too.
Well, I'll tell you, over here, you can see their new air intake system for their engine.
Let's follow that new air intake system. Show us.
Okay. Well, Richard, the air will come in this area right here, goes into the pre-cleaner. Their pre-cleaner is aspirated by the fan. Now, when you fan aspirate a pre-cleaner, if the viscous clutch would happen to disengage, you would lose your pre-cleaning ability. Now, you know, Magnum uses an exhaust style aspirator, and you know, the exhaust will be working at all times, which I feel is a very good feature for the Magnum tractor. All right. Now, after it goes through the pre-cleaner, well, you know, that's a lot of plastic up here, and we're starting to go through some connections. All right, pre-cleaner goes right along here. Plastic pre-cleaner system goes across. Well, they've got a heat shield over here to protect that plastic from the engine heat on the back here. Goes on back through here and drops down into the air cleaner. You're going to have to take it on the other side, Richard.
Okay, the air comes out of the air cleaner here, goes through this molded rubber hose and into the turbocharger, which is mounted behind the engine here. Obviously, to keep the hood profile down and a bit narrower. The Magnum turbocharger, by the way, is mounted at the center of the divided exhaust manifold to be able to take full advantage of the heat and exhaust pulses for better turbocharger operation. The air comes out of the turbocharger, then on top over here through this black hose and tube over here. This comes down through this steel tube to the front of the tractor and across over the top of this water pump or this fan gearbox and over and down to your side over there, Walt.
Okay, Richard, I can see the tube coming from your side over to this side here. It goes all the way down to the base of the radiator where it enters the air-to-air heat exchanger. I noticed that the air-to-air heat exchanger is located directly behind the hydraulic oil cooler, meaning that there's a lot of heat being transmitted from this area back into the heat exchanger, which could affect the efficiency of it. Not saying anything about the air being disturbed by all these tubes up here. All right, once the air comes into here, it goes down this tube here and into the intake manifold. Now that is a long ways around. In fact, it's gone full circle of the engine.
About how far do you think?
Well, we ran a quick measurement of it, and it's about 25 feet.
Yeah, the Magnum's a little less than 5 feet, I believe.
The Magnum is a little less than 5 feet, so that means that the Magnum intake air is going less distance, has less restrictions, and has less chance of having any interruption with any seepage or anything that could go along with any couplings.
Any dirt getting in there or any of that stuff, you bet, a lot less chance.
Yeah. Okay, well, Richard, let's take a look and see what happens now as it goes into the intake manifold. We now have the air entering the intake manifold, which is a bolt-on design. This intake manifold is bolted onto the head of the engine and is located directly above the exhaust manifold. Now, as this unit is bolted on, you will have a possibility of misdirecting some of the air as it flows into the combustion area of the engine. Now, with this intake manifold directly above the exhaust manifold, and you can see it's quite hot because they have these heat shields right here, it will have a tendency of perhaps increasing the heat of the intake manifold and therefore increasing the temperature of the air inside. Can you put your hand in between the intake manifold and the exhaust manifold?
I can't even get my pencil through there.
You can't even get your pencil through there. Okay, so that proves that the proximity of the exhaust manifold is very, very close to the intake manifold. All right, now you take the Magnum tractor, has a cross flow head, meaning that the intake manifold is on one side of the head and it is built into the head. It's a one piece. The intake manifold and the head of the engine is one piece. Provides us with a very smooth flow of air into the combustion area. Now, the exhaust manifold is on the opposite side. That's where it gets the term cross flow head. By putting the Magnum exhaust manifold on one side and the intake manifold on the other, helps eliminate a lot of the heat transfer that would occur between the exhaust and the intake manifold, and avoids what is occurring between Deere's exhaust manifold and intake manifold.
Yeah, sure would. You couldn't get any if it's on the other side. Yeah, boy, I see this intake manifold is really high. It's above eye level, in fact, on this engine.
Well, I'm glad you noticed that, and you couldn't have seen this if we hadn't taken the hood off. Now, they've been able to make a major change in their design by removing the fuel tank that has always been in front of their tractor, in front of the engine, and they now place it in underneath the cab. All right, by doing this, it's allowed them to raise this engine 10 inches and forward 44 inches.
Wow.
Now, you'll notice that casting that's right over by your left hand is quite wide. In fact, in measuring that casting, that's 30.5 inches wide, which is actually wider than 30-inch row of corn, wouldn't it be?
You bet.
You bet. All right. However, when you come back into this area here, you'll notice that they have a very narrow design. They call it a wasp waist. Now, what they achieve from this wasp waist design is it allows them to turn their wheels very tight and get them close into the engine without any side rails. All right. Sure. This provides them with the ability of turning in 12 rows of corn and 12 30-inch rows of corn. Mm-hmm. Now, the Magnum can also turn in 12 30-inch rows of corn.
It looks like an all-new engine since they've removed the side rails and made the block a structural design. They mount the front axle to the oil pan. This does give them more room to turn the front tires, and of course, Walt, as you can see, it does, as you mentioned, give a little more view for the operator down to the ground in the axle area. They use a steel midframe between the transmission and the final drive. That's what ties the tractor together between the transmission and final drive to take their torsional loads. On the other hand, the Magnum has 2 1/2-inch closed box side rails to handle the torsional loads. And also the engine has 2 ISO mounts on the Magnum tractor.
Richard, this might look like a new engine, but it actually has retained a lot of the old designs that they've used previously. One of the designs that they've retained is the Siamese valve design. It's best illustrated by using these valves right here. The intake, exhaust, exhaust, intake. Now, it gets named Siamese valves by the fact that they use two exhaust valves side by side. By doing this, they have a potential of creating a concentration of heat right in between these two valves. Now, this will require the cooling system to work harder to maintain a constant temperature in the engine. Now, Magnum has an entirely different valve design that we've used for years. Now, they call it the alternating valve design. The way we do this is we remove the exhaust valve, put in an intake valve, and put the exhaust valve down here. Now, by doing this, we get the alternating valve design. Intake, exhaust, intake, exhaust. We separate the two hot exhaust valves by the cooler intake valves. Therefore, we eliminate the potential of creating a hot spot in between the exhaust valves.
That looks like a real good idea. Let's go look at the cylinder sleeves.
Okay, Richard, let's do that. Here are the sleeves, Richard. Now, this is the John Deere sleeve. This is very similar to the sleeves that they've used in the past, in the design where they actually clamp the sleeve in the block at the top, and they fit the base of the sleeve in the bottom of the block with 3 O-rings and this taper. Now, with the 496 engine, they have added a coolant groove in the block to cool the top part of the sleeve in the 496 engine because of the increase in the horsepower and, of course, the temperatures. Now, you take the Magnum sleeve, looks considerably different than the Deere sleeve. This is what we call our mid-stop swirl cool sleeve. This mid-stop sleeve is actually clamped into the block at this point right here, and it is positioned in the block at the top. Now, from this area, from the clamped in area to the top, is where we have our swirl of coolant going around the sleeve. Now, every sleeve has its own water jacket, and there are 2 orifices that direct coolant around the sleeve to assure a proper temperature in every sleeve. The lower part of the sleeve is cooled by engine oil.
You know, looking at the size of these sleeves, and that reminds me of the engine displacement. And my understanding is that Deere still uses the old 466 in their 3 smaller models of the 8000 series, the 8100, 8200, and 8300 tractors. And that they further have increased the stroke on that engine and call it a 496 now. Use that in the 8400 tractor at 225 horsepower. Right?
Right. Well, now that we got this part covered, let's take a look at the water pump and the fan.
Okay, let's do that. Okay, Walt, here's the water pump area here, sitting in these 2 housings on this 496 in this 8400 series tractor. You can see it's obviously gear driven. That water pump pumps 81 gallons a minute to keep this engine cool. And remember, on the Magnum, the 505 cubic inch Magnum engine, the water pump pumps 67 gallons a minute only, a power saving 67 gallons a minute, which very efficiently cools that engine, and it's belt driven as well. You know what? It only takes about 15 minutes if you ever had to change that water pump on that red tractor, and it only would cost about $100. You draw your own conclusion. Let's look at the fan drive. The big viscous fan drive on here, it's gear driven as well. You can see it's driven by its own dedicated gearbox with its own set of gears and oil, and see a little breather on there.
Well, you know, Richard, I see all this. Where's the air conditioning compressor and the alternator at?
Let's go take a look at that.
Okay.
Okay, Walt, right back here behind the transmission is where the alternator and air conditioning compressor are located. They're driven off the top shaft of the transmission by a poly V belt here. Now, this is I would gather, a very hot and dusty location back here, and rather difficult to service. See the mountings and the way the belt is on there. Now, on the Magnum tractor, these components are in a conventional position up on the front of the engine in the fan blast. Walt, this transmission looks kind of narrow. Let's talk about it.
Okay, Richard, well, I'm glad you noticed that, because this transmission is only 22 inches wide and was designed to work in relationship to the wasp waist design, so for better vision. All right, now, when they designed this transmission, it is a total new transmission. They used to have a planetary drive transmission, and now they have gone to a countershaft transmission, which is similar to the Magnum tractor. Now, the countershaft transmission has the input shaft, countershaft, and output shaft. One other area that they made a major change in is that they now have straight cut gears. It's a deep cut straight tooth gear. It is very different than the Magnum in the fact that the Magnum uses a helical cut gear, where we have constant mash, and it is a very quiet running transmission with helical cut gears. Mm-hmm. Now, with the Deere 16-speed transmission, they also have a 4-speed reverse. Now, with this unit, they have got a full control of this transmission from the operator's armrest. They call it the command arm. It's a little stub shaft, and it electronically controls all the shifts in the transmission. Now, the transmission has, from 5th through 12th gear, a 13% gear change. That, they call that their working range. All the other gears prior to that and after that are 27% difference in speed change. 27%. Now, you compare that to the Magnum transmission, and we have an average of 15% space between each one of the gears.
All the way to 18?
All the way from first all the way through 18 gears. And we also have 4 reverses. Now, you take this transmission right here, and a good example is that you shift from 15th to 16th, and you have a 6.5 mile an hour increase in speed. Now compare that to the Magnum. When we shift from 17th to 18th, we only have a 2.5 mile increase in speed. So you can see the advantage of having an average of 15% gear change throughout the entire transmission range. For optional, we have got a creeper gear transmission that Deere does not offer, which gives us an additional 6 forward speeds and reverse.
John Deere now has a new 7x7 dedicated master clutch on their new transmission. 7x7 meaning 7 plates, 7 inches in diameter. Of course, Magnum uses 9x9, 9 plates, 9 inches in diameter on their mid-mounted master clutch. And the one big difference is that the Magnum master clutch is self-modulated and the Deere is not self-modulated. Walt, I see here in their operator's manual that they have, if I count them right, 63 diagnostic codes associated with electronics of this transmission. That means a minimum of 63 potential problems that can be monitored on this transmission with their diagnostics. They also have what they call a come home feature, and back behind the cab here in the wiring harness, you pull the cover off and you can disconnect a cap off of a connector, plug it into another connector, and plug the cap into an opposite connector, and it will allow you to be able to come home if you have a transmission failure. You can operate the tractor in a forward speed of 4.2 mile an hour, or you can back up at 2.9 mile an hour. Now, of course, on the Magnum transmission, it's a mechanical inline shift and you don't have electronics. You don't have those things to be concerned with. Could you tell us about the cab?
Richard, this new cab features 62 square feet of glass. Now that includes this one-piece glass windshield and even the glass that's located in behind the engine. Also included in that 62 square feet is this glass door. All of this to help the operator have better visibility. Another thing, Richard, is they have also moved the main instrumentation from the conventional location in front of the operator to the right side of the cab. This new 8400 series Deere tractor went through the official test and had a 76 dBA sound level. Now the Magnum went through the tests and it recorded a significantly lower DBA rating of 73.5.
Wow.
That is great for Magnum.
You bet. Deere's gone to electronic control of their hydraulic detents and flow adjustment on their hydraulic system. Their hydraulic system produces 30 gallons a minute from the couplers and has up to 2,900 psi. They do not have a priority remote valve like the Magnum tractor has to provide a constant flow to any one circuit. Deere's operator's manual says, and I quote, "Flow priority is to the lowest pressure function," end of quote, which means the same as the path of least resistance, which says that they don't really have a priority system like the Magnum has, which will provide constant flow on number one valve. Okay, Walt, let's move to the back of the tractor.
Well, Richard, we've talked about the Deere engine, we've talked about the Deere transmission, we've talked about the mid-frame that holds the front end of the tractor to the rear end of the tractor. We've discussed the cab, covered the hydraulics. Now let's briefly mention something about the final drive of the tractor. You know, from the transmission, they have a drive shaft that goes in, drives the pinion gear, that drives the ring gear. Then it gets into the differential. Now there's where we're coming into some major differences. Deere transmits all of this power through 3 pinion gears, where Magnum transmits their power through 4 pinion gears. A significant difference.
Okay, well, let's talk about their independent PTO. Deere has available for all models an optional setup that means that they can not only run the 1 3/4 shaft setup, but they can run a 1 3/8 inch shaft in either 540 or 1000 RPM. And they do that with a shear collar in there. In the 540 position, that's capable of 75 horsepower. And in the 1 3/8 position, that's capable of 150 horsepower. Now on the Magnum tractors, on 3 models, we have 2 shafts, a 540 or 1000 RPM shaft available. And on 2 models, we have a 1 3/4 inch 1000 RPM shaft only available.
Okay, Richard, let's compare the standard hitch lift capacities of the 8400 tractor and our tractor.
Okay.
Now, the standard hitch lift capacity of the 8400 tractor is 11,700 pounds, and that's achieved by 2 external cylinders. Now, the standard hitch lift capacity on the Magnum is 14,950 pounds using 2 external cylinders, plus we have 1 additional cylinder internally.
Very good.
Now, we've got all the way to the back of the tractor, so let's go through a summary of what we've been through now.
Okay.
Deere has a bolt-on hood.
And Magnum's has a tilt hood.
Well, the Deere has a 466 cubic inch engine and a 496 when you get into the 8400.
Magnum has 505 cubic inch case engine.
The Deere has a 16x4 power shift transmission.
And of course Magnum has 18 speeds forward and 4 reverse power shift transmission.
Deere has a mid-mounted master clutch.
And the Magnum has a mid-mounted modulated master clutch.
Deere has an electronic shift.
And of course on the Magnum it's a mechanical inline shift with positive operator feel.
Deere has a single shaft independent power takeoff.
And on the Magnum you got 2 independent power takeoff shafts available on 3 models.
Deere's hydraulics are electronically adjusted.
And of course on the Magnum all of the hydraulic adjustments are mechanical.
All right, the Deere 8400 has a 76 dBA sound level.
And the Magnum has 73.5 dBA sound level.
Well, we've covered most of the major changes, and we hope that this information is helpful to you. We certainly know that Deere has designed a tractor to be competitive with the reliable Magnum tractor that has 50,000 units in the field and still counting.
Walt, you put the hood back on the Deere. I'm going to go close the hood on the Magnum.
I think that's a bad deal.